I have turned on my recorder, and it is exactly 11 o'clock, I see. Okay, today is, excuse me, 9/25, 2019. This is the regularly scheduled meeting of ITSC 2309 at Collin College, Frisco, Texas. And let's see, the time is 11 o'clock, so this is our time to begin. And today we are in Module 6A. Yes, is that right? So Module 6, and then these are 6A down here. So this is the next one. So we in this particular chapter, we are working with joining tables, and joining tables is essentially a way you follow the foreign key to the primary key or vice versa, and you put the tables together. So it would be, I want to see the parents and all their children in one table. And we talked about the inner join, and if you use an inner join, that means that you only see parents and or children that participate in the relationship. You do not see parents with no children. You do not see orphans. You do not see invalid children. And so that's a downside to the inner join. The inner join is probably the most frequently used. The outer join lets you see other information about the table, but you need to know a little something about it before you use it. And it's a place where most people have issues with understanding what's going on. So an inner join, it essentially builds every possible row is the way we developed it. So it puts together the foreign key and the primary key in every possible permutation, combination. And from there it goes in and it finds the ones where the primary key and the foreign key match. And so that's kind of a way of looking at it. And so when you join like that, if I say where the foreign key equals the primary key, if the primary key doesn't have any foreign key children, it'll never be equal. So I can't find, using an inner join, I can't find childless parent. Outer join, when I look at an outer join, in an outer join, I have, get this one, bring it up here. Here's an example. Well, let me pull up an outer join that I have right here. In an outer join, if I look at the from line, one of them is on the left and one of them is on the right. One of the tables is left, one of the tables is right. In an inner join, it does not matter which table comes first in the inner join. You can put either of them first. It's all the same as long as you get that join field right. So table A inner join table B is the same thing as B inner join table A. But when you get to an outer join, one of them comes first and one of them comes second. And in the Western culture, we read from left to right. Therefore, the table that comes first is considered to be the table on the left. The table that comes second is considered to be the table on the right. So when I say left outer join, what I use, my vocabulary, the way I say the outer join points at the left table. A right outer join, the outer join points at the right table. Now, the order does matter. If I change the order of the two tables and I change the left outer join to a right outer join, you would have the same thing. Okay, so the order matters given that you keep the left outer join and right outer join. When I talk about an outer join and I say a left outer join, that means that I will see all of the records from the left table, whichever one it's pointing at, I will see all of the records from that table. And unless I say otherwise, I will see all of the records that do participate in the outer join. For example, when I say select vendor name, vendor ID, so there's I.vendor ID, V.vendor ID, I.vendor ID, vendors and invoices. From vendors, left outer join invoices, where the invoices are equal, I'm going to see everything from the vendor's table. All records from the vendor's table. Now this will show me the childless parents. I'll be able to tell the difference. So when I run this, I'm going to see all of the records from the vendor's table. So I execute, and I have 202 rows. Okay, notice I've got a lot of nulls in here. As I scroll down, I see some of them, for example, IBM vendor ID 34. Hey, I have 2 of those and they're not null. What's going on with vendor ID number 34? Vendor ID number 34 has invoices. Vendor ID number 37 has invoices. But what about vendor ID 35? Doesn't have any invoices. So the outer join is showing me this is a childless parent invoice. Notice that what is the parent? The parent is the vendor's table of this. The foreign key is down in the invoices table. So the outer join, we say, points at the parent table. I want to see all of the records from the parent table. Now, usually, generally, what you want, you're not particularly interested in all of these nulls. You might be, but most often you are not interested in them, or you are probably interested in where it is null. So most of the time, what am I interested in? I'm trying to find parents with no children. So I want this one, R.R. Boker, I guess, and this one, but I don't want IBM. So which records do I want if I'm searching only for childless parents? I want them where the child is null. So I point at the parent where the child is null. So to find childless parents, point to the parent. I will usually, just by my way of doing things, I will usually put the primary key, the parent table, on the left. I do more left outer joining than right, but that doesn't mean you can't do it the other way around. You can switch them if you want to. It's just you just have to switch the left and the right. One of them's on the left, one of them's on the right. It points at the parent. So to get childless parents, you point the outer join at the parents. Now, a couple of things that I'm sticky about in this class. We will write a left outer join like this, left outer join. Okay. Now, some of you have used SQL before, and you realize that you can just say left join, but not in this class. When you want to take my advanced class, you can say left join. Just like with inner join, you can just say join, and that's an inner join. If you say left join or right join, well, that's an outer join. But in this class, you have to say left outer join or right outer join. Fussy about that in here. Now, does it work in all SQL? To the best of my knowledge, it does. I think it works. All of the platforms that I have seen, it works on, but it might not, because the specification of SQL says you have to say left outer join. And later, when you're on Oracle or SQL Server, if you want to drop the outer, that's fine. I mean, you're not my class anymore, so I guess whatever you do is fine. Okay. Now, if I execute this, I see only childless parents, and I see 89 rows. I guess I got an extra one in there. I was thinking it was 88 rows, but now notice that the vendor ID, I.vendor ID, is just null, 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 null. So really, why do I want to see that? It's going to be null. I mean, how does it get in there? It gets in there, it gets into the query by being null. So do I really want to see a whole column full of nothing but null? It doesn't tell me anything. So I could just drop that column out, and probably would, because I know those are the ones I want. I'm going to get the same answer, and it makes more sense without cluttering it up with, it doesn't make a whole lot of sense if I'm asking for show me all the vendors where the vendor state is California. It doesn't make any sense to show the vendor state unless you just want to see it just to make sure your query's right. Maybe you do. But probably I would suppress that because I know it's going to be CA on all of them. Questions? Childless parents. Outer join points at the parents. Usually where the child is null. Yes, ma'am. Mm-hmm. Sure. I'm going to take him out for right now. Okay. I have an outer join. An outer join is, an inner join shows me only records that participate in the relationship. So if I said inner join, I'm going to see the parents and all their children. So if I change it just a little bit, so if I change it, if I do an inner join, when I execute that, I get 113 rows, but I see, notice I see the vendor names are, well, lost it. The vendor names get repeated and the vendor IDs are down there. So the vendor names and their children. So so these are the vendor names. I didn't put I should have put the invoice ID in there. I don't need to say I.invoice ID. Notice now I'm seeing the vendor name, vendor ID, and all their children. Now the two vendor IDs are going to match because they have to. It is it's an inner join. If I change that to an outer join and I want to find the childless parent, I make it a left outer join and I say it is pointing to the left. Could be a right. And it points to the table that comes first. From that table, I'm going to get all records. I could add the invoice ID in here, but there's no real reason to. So when I execute this, I get a lot more. I get 202 rows, but I have a lot of nulls. The ones that are not null are the ones that have the invoices. They're the ones that participate. So I see all of the records from the parents, from the parent table, from the primary key, if it's pointed that way. And I see only, and I see the records that participate from the child table, if it's pointed away from the child. So for childless parent tables, to find parents with no children, point at the parent, and I will typically say, because if I'm finding childless parents, IBM, let's see if I can get it here. Where? Vendor ID? Well, I could show the invoice ID. I'm probably, it's okay to put it in there. It's going to change it a little bit. Where will I see? I'll see an invoice ID for here and here. Here I'll see invoice ID. The rest of them are all going to be null. Why? Because all of those that have a null vendor ID also have a null invoice ID because that particular parent has no children. I'm seeing that parent because I see the parent. I see all of the parents from that upstream table, the one it's pointing to. So most of the time.
So left outer join is used where there is no relationship?
No, there's a relationship.
Yeah.
Remember, I talked about the inner join. Inner join, both sides must participate fully in the relationship. So show me parents and children, where the child ID matches the parent ID. If the parent has no children, that is never true for any record, for any row. Therefore, the parent will not appear in the output. A orphan will not appear in that output. Okay. Usually what I'm interested in when I do one of these, I usually want childless parents. Now, maybe I want to see all of those nulls. Maybe I'm, maybe I'm interested. I could be. But usually I'll say, find me the ones with no invoices. And usually look like this. Now, all of those are going to be null. All of the vendor IDs, all of the invoice IDs, there's 89 of them there, all of them are going to be nulls. Why? Because that's how they got in the query, was by being null. So they're in the left outer join and null. Those are the childless parents. So probably I'm not interested in those. Most likely. But I am interested in where it's null. So now when I select from it and I say execute, I'm going to see the information, but only the information that pertains to that parent. Now I had to look at both tables. To tell that I didn't have any children, I had to look at the parent table and the child table. And I had to join the two tables. And then I said, okay, now just give me the ones that don't have any children. Am I making any sense? Questions on the internet, people? So a very common use for an outer join. Another common use for an outer join. Invalid children. Remember, we're not supposed to have any invalid children. Yeah, right. The world is always supposed to smell good, but it doesn't. So when it doesn't, what do we do? Well, how do we get in this position? Somebody sets up the tables wrong and they don't create a foreign key. And this will happen all the time if we were using the Shelley Cashman book, you just start out and you start throwing data into tables and Access, and students will always make a typo. And when they type the foreign key, they will always misspell it somehow. And then they come along later and they try to create the relationship, and it says, no, sorry, you have invalid data in there. But it doesn't tell you what it is. It just says, sorry, we can't create the relationship until you deal with it. Or sometimes they go ahead and create the relationship anyway, and you have bad data in there. And so what you have is a corrupted table. You have bad data. I want to find those bad data. Bad data, yeah. So what am I going to point? Where am I interested in? This one, and I'm trying to find invalid children. Where does it point? What? Well, I know, but I got two tables. So I've got a parent table is the vendors, and the child table is invoices in this case. I want to find the invalid children. Where will the outer join point? Point to what? Well, for finding childless parents, we pointed at the parent. Now I want to find parentless children, essentially, which is invalid children. Where do they point? Points to the child. And it points to the child. Since it's going to point to the child, I'm going to get everything from the child table and only those records that participate from the parent. Now, in this case, right? So I will generally put the parent table on the left and the child table on the right, but there is no rule that says you have to do it that way. You can do it whatever works. So I generally have some kind of a method to my madness. This is the way I think when I do it. I think parent on the right, child on the left, but rules are made to be broken in this case. So I'm going to do this. I'm going to say write outer join invoices. Now I'm going to see all of the records that participate. So there they are with the parents and the children. And I guess I can put in the invoice ID. Might show a little bit better. So there's the parents. IBM has invoice ID 19 and 52. Blue Cross has invoice ID 46, 50, and 113, and so on. So that's just a plain old inner join happening there. What happens when we go down and we find, do we see any children with no parent? What do we have there on row 114? See if I can bring that up on the screen a little bit more. Well, I'm not able to get it to come up on the screen, but on row 114, can you see that? Row 114, I have a null vendor name and a null vendor ID coming from the vendor's table. In other words, I have not matched a record in the vendor's table with that invoice ID number 68, with the vendor ID foreign key of 999. There is no vendor ID 999 in the vendor's table. Therefore, that is an invalid record. What should I do with that record? Well, I could delete it, yeah. A database person will cringe at the idea of deleting a record, though. We go, oh no, you want to delete a record? Well, there could be a lot of data there with it. I mean, right now it's just a small little record, but you know, maybe it has grandchildren associated with it. I mean, it could be quite a bit of data there associated with that one record. What do we do? What could we do? Okay. I'm in kind of between a rock and a hard place. I really can't just start deleting data. Most of the time databases will, and you'll learn how to do this next semester. In fact, that's a topic of my discussion tonight in the advanced class, is how can I stop you from deleting anything from this database? What I would do, I would go over to the vendors table, to the parent table, and I would create a dummy record over there. And it would have vendor ID 0, or maybe -1, something that is invalid. And I would call this guy, this name is the parent of orphans. I mean, the place where I put them when I don't know what to do with them, because I've got an invalid parent. So I need to put an invalid parent in there, such that when that invalid parent picks it up, now he's got a valid parent. And I can go back and later I'll do something with it. When somebody comes screaming that, oh no, I can't get to my data, at least I haven't deleted it. It's still there. So I would create the record, I would insert the record, something with an invalid, that I knew to be an invalid, it would be a valid vendor ID because it's in the table, but it's not really there. It's just something I put there because I had to have a parent. So I put it there. Then I would give this guy that parent. And anything else that was giving me trouble would end up there.
How did you make that last row? I mean, I executed the same, but I'm the 14th number row. I just cannot get that.
I'm sorry?
How did you make the last row? Like, how did you create that? Because on my...
Talking about this where it says null? Okay. What does your query say?
Yeah, so I kind of like you copy pasted the last one.
Okay.
I-
do you have this part right
Yeah.
here? Do you have this part from vendors right outer join invoices? Do you
Yeah,
have?
I do.
Uh-huh.
You did add it to the last one.
Well, I don't know. Oh, you don't have a null?
Just check.
I don't know.
Wait, let me check. Let me execute if I can. No, I don't have
Okay.
that.
Gee whiz, you don't have a null, and you don't have an invalid one in there, huh? Okay. Well, I'm told that you don't have an invalid one in there. I'll give you the code to run that will create it with an invalid one in there. It's easy to do. So I probably just didn't. I I guess I just didn't give you the. I need to update that one on the web page. So the way I got it was I can always tell. I can go to the data, and if I go to the Object Explorer, and it's time. I guess it's time we started talking about the Object Explorer. This guy over here. This is our graphical user interface. And this isn't a class about using the graphical user interface, but it sure is nice to have. Good grief. I mean, if I have one, I may as well know how to use it such that it helps me understand my SQL. There's nothing wrong with them. If I go over here and I go to databases, if you have a database called ADV AP, that's the advanced class. Don't worry about it. APDB, go to the tables. One of the tables is invoices. That's where the data are. If I right click and I say edit top 200 rows, there should be a vendor ID of, there's the vendor ID right there of 999. Invoice ID 68. I don't know what, I don't think that you can change that. I think it will stop you if you try to change it.
It's weird. I don't have an invoice ID 66, 67, 69.
Okay.
So
Well, I'll give you we'll run the creation script again, and it'll create it. It's trivial to do. We'll do that real quickly. By the way, for those of you out there in internet land, I'm told that some of them do not have this invalid one in there, and I'll make that available. I will upload the correct SQL script that creates it with the invalid stuff in there. Make sure we have it. But you know, whether your query is correct or not does not depend on the data. It's just nice if you're seeing the same things that I am.
well, my question was that how did you create the dashboard? So it was like you added the invoice is
I put it in there when I created it in the
for invalid children.
right. Well, when I put the invalid one in there on purpose. When I wrote the script that create ap.sql, I put code in there that would insert an invalid data. So I had to override the database objecting and say, okay, take it anyway. So it did, and then turn it back on. Like I say, I'll give you that code. I've got that code right here on my computer. Okay, questions. Now, let's see, since this one is probably invalid children, I'm probably only interested in the invalid children. And again, this one, when I had pointed it, I pointed it at the child. By the way, I will typically close down this Object Explorer. If I exit out, it goes away. If I want to bring it back, I go to View, Object Explorer, and it comes back. This one, I'm probably going to say where. Where the parent. So notice this one, I'm pointing at the child and I'm saying where the parent is null. You see kind of, so that gives me just the bad data or datum, whatever. And so your query would still be correct whether you got anything or not. If your data weren't the same as mine, that's fine, but your query would still be correct. Now notice it points at the one I'm looking for. So I'm looking for parents without children. It points to the parent where the child key is null. If I'm looking for invalid children, it points to the child where the parent is null. Okay. Those are the two biggies. Count on one of those. We are coming up on test 1. So where I wrap up here today, that will be test 1. Now the questions in the book all involve childless parents, and I tried to couch them in kind of a word problem. Let me go with this. Okay, unmatched foreign keys. This is how it happens. This is how you get bad data in there. If I execute this command, alter table child, or in this case it would be invoices. So I would say alter table invoices, no check, constraint, and then the name of that constraint of the foreign key. So I say don't check the foreign key, and then I can do anything I want to, put bad data in there, and then I can turn it back on, and then I'll have bad data in. So that's the way I did it. Common use for this, finding childless parents, been over that. Childless parents point to the parent where the child is null. Parentless children, meaning invalid children, where a child exists. It says he has a parent, but that parent is not in the other table. Point to the child where the parent is null. What about finding orphans? What's an orphan? Orphan has no parent. Now, an orphan does not have an invalid parent. An orphan has no parent. I can tell an orphan, all I have to do is look at the child table. And I can tell an orphan, why? Because the foreign key is null. I don't have to do a join to find orphans. Lots of times, that's a common mistake that people make in database. They'll join the two tables. Now, a table join will find orphans also, right? If I have an orphan, the invalid child query will find the orphans. But I'm really interested in invalid ones there. All I have to do is look at one table to find an orphan. I just search the child table where the parent field is null. That's an orphan. Okay. Exercises. I want you to use that term, outer, left outer join, right outer join. Let me go over these. Write a select statement that returns 2 columns from the GL accounts table. Account number and account description coming from the GL General Ledger Accounts, GL accounts. Should have 1 row for each account number that has never been used. What am I talking about? I tell you that in here. I say an account number has been used if it appears in the invoice line items table. An account number, when an account number has been used, it has a child. What is the parent? The parent is the GL accounts table. The child is the invoice line items table, and I'm looking for childless parents. So I'm hiding it a little bit. I'm trying not to just really hide it well, but I'm trying. This is how you will see it. And as you're programming, you'll need to figure out what kind of a join do I need here. Do I need an inner join or an outer join? So it's a outer join. Invoice, right, SQL query. All of these are outer join, by the way. Invoice line item from the invoices table that do not appear. So all of the invoice ID. So invoice ID values from the invoices table is the parent. Invoice line items is the child. Now, how can I have an invoice with nothing on it? That's probably an error, but I'm not asking you to fix it. I'm just saying write the query that'll find it. Let me go move on a little bit here. Wrap up. Okay, this one just says it again. There is one more that is mentioned that SQL Server provides, and that is called a full outer join. Full outer join has everything in it's an inner join, and all of the records in both tables, in either of the tables, okay, that are unmatched. So a full outer join isn't very useful. For the most part, when you use a full outer join, you're probably doing a lot of extra work in the computer that you don't have to do. So I'm going to focus on left outer join and right outer joins. So when the outer join points to the parent, where the child is null, you're finding childless parents. When the outer join points to the child, where the parent is null, you are finding invalid children with invalid parents. Those are the 2 primary uses for an outer join. Really, and the rest of them are probably going to be inner joins. Now, like inner join, where inner join I can stack up multiple tables. So I say I can follow it through several different tables. Outer join, you can do the same thing, but you usually don't do it as much. It is common, fairly common, to have an inner join and then find everything that's in the inner join and is not in another table. That's fairly common, but not as much. We just don't use outer join. We don't use a full outer join, meaning I want everything from both table and everything that participates in the relationship. Okay. What do I have? Okay, let's see. There's one more there that I said we won't worry about. We're not going to worry about. We won't worry about cross join. I'm going to talk about what they are before we get out of here. Right now, we're coming up on test 1. What am I going to ask you for on test 1? Oh yeah, okay. We're going to create 2 tables, and with a foreign key. kind of like what you did. And you will insert some records in there that have foreign keys. So think about, how I might do that. Doctors, patients, owners, pets, cars, and manuals, where manual can cover, a manual covers exactly one car. A car is covered by 0 or more manuals, I guess. There's lots of ways I can do it. So I want you to be able to create 2 tables, put go between them. At the beginning of it, I want you to drop the tables in the correct order. Remember, we dropped the child first, then we dropped the parent. Let's see, then the next thing we did after we created tables, we inserted data. Okay, so there's going to be that component to it. Then let's see, the next one was this basic select from where. We can have a field that is derived, meaning it can have, select field A, comma, field B, A plus B as C. Okay, so if I tell you to have a field that is calculated, you have to give that one a name. You can name it X. Okay, got to name it something. Let's see, and then after that we had we had order by, we had the where clause, so select from where, and the where's in there, the where being and or, greater than, less than. Then we did joining tables, we did inner join. So I'm going to ask you, inner join follows the parent-child relationship. It will always be a foreign key primary key. So the inner join, if you're inner joining and you're not joining on a foreign key primary key pair, it's probably wrong. You don't need to join your IQ to your shoe size. It doesn't make any sense. They have to be somehow related. If they're not related, it doesn't make any. Yes, I can join your state to your city name. Find everybody in the who lives in a state where a state name is the same as a city. So if I lived in a state that had a city named California, it would make sense. I don't know why you'd want to know that. Okay. And then we're going to do outer join. What 2 questions am I going to ask you to do on outer join? Well, I'm not going to say do a right and left outer join. I'm going to say find, what am I going to find? Find childless parents and, you said it, in the parentless child. Parentless child, yeah. Yeah, a child with an invalid parent. And I might throw in an orphan, find the orphans to see if you do that. So finding an orphan, find all of the orphaned records. Any record who does not have any parent. That's easy. I can tell that by just looking at the child. I don't have to have a join at all. It's just where that foreign key is null, because that foreign key may be null. Now, primary key can't be null. Foreign keys can, unless there's something that says they can't. And that would be a constraint. Says, I'm not going to let orphans be in here. Okay. I'm going to, yeah, it's going to be online. I'm going to enable the test 1, and I'm probably going to go ahead and enable it today and ask some of our online people to take a look at it, somebody in there, so to check and make sure that it's valid or that everything's up on it. Let me go to it now. Next, I think I'm going to get it. Chapter 4 quiz. Quizzes are pretty easy. Okay, practice test 1. I've only got 5 submissions. I need to have some more coming on this. When did I say? Due was September 25th, so it's due today. I'm going to give you another couple of days on it, but then I'm going to cut it off. Okay. So you can get something turned in, even if it's, you know, you can work on it, but you should do that before you do the test. Let me, no, I'm not going to change the due date, but I'm going to cut it off here because I am starting test 1 now. So I want you to get it done. Let's see, the 25th. I'm going to cut it. I'm going to give you till Friday to get it in. I mean, it's not the end of the world. It's only like 5 points. So, okay, test 1's coming. I'm doing test 1 right now. Let's go. Practice test discussion. You get some points for doing that. Practice. Oh, I need to put these solutions out there. So here are the solutions. These are my solutions to practice test 1 that you may look at. Okay, it's not going to do you a darn bit of good if all you do is copy my solutions and then turn them in. That's why I usually make you turn it in and then I give you the solutions. These are my solutions. Your mileage may vary. Just because yours don't look exactly like mine doesn't mean that yours are wrong. This is just what I did. Okay, this is the test 1. Test 1 that says do not access the test until you are ready to complete it within 3 hours. I'm lax on the 3 hours. Okay. If it's 3 days, I'm not gonna be happy. The other point is that this test will have to be in on the due date at the due time. Do not go past the due date. When you follow the next line, you will begin test 1. Okay. So this lets you, 100 points total. Edit. Okay. I'm going to make this due. Wednesday, Thursday, I'm going to make this too. So I'm going to give you the weekend on it. Now I want you to do it pretty much. I mean, if you got to get up and take a break, we'll take a break. But in general, get ready to take the test, sit down and take the test. That's what I'm trying to get you to do. So I'm going to give it till Monday. And the until, it's going to cut off at 11:59 on Monday. Are we clear? So at midnight Monday, it turns into a pumpkin. Always, it doesn't matter how much time I give people. Somebody is going to say, "Oh, I just forgot about the time." Don't forget about that time, right? You don't have to fret over the 2.5 hours or 3 hours or whatever I said on that. I'm not too much worried about that. I need it in at the due date because I can't have these tests trickling in. I can't grade them until I get them. And I have to sit down, I have to grade everybody's problem 1 and then everybody's problem 2. And so it takes me a lot of time to grade them. Okay, let's publish it. Here we go. Amanda, are you there?
Yes, sir, I'm checking it now.
Would you please try to access the test and let me know if you can see the test? In other words, if you can bring up the document. It's a Word document. Let me throw 9 test 1.
Do you want me to enter into the document?
I just tell me if you can see it. Can you see this Word document?
Yes. Well, I can see the link to the document.
Go ahead and execute that.
Okay.
And I want to see if you get it. And can you access? You go ahead and try to access it. Go ahead and follow the link. That one. Go ahead and hit it.
Yeah, I got it.
Say. Okay, it looks like it's opening here too. Yeah. Okay, go ahead and close it until you're ready. Okay, close it until you're ready.
Okay.
I just wanted to make sure. Sometimes, there's so many things that you have to, particularly when I'm hiding stuff at the beginning, then I go to turn it back on and I forget to the container that it's in is hidden, then you can't see it. So it's like if I'm trying to make it available to you. When does the clock start? Yeah.
I mean, yeah, will it give the time? Will it show up the time, for example?
No, it won't. You just get your.
Just like,
Listen, I'm not gonna fret a whole lot about how long does it take you to do the test. Okay. You know the difference between 3 hours and 3 days, right? Okay. I want you to sit down and do it. If it takes you 2.5 hours, that's fine. If it takes you 3 hours, that's also 3.5 hours. Okay. I'm not gonna fuss over that. Watch your time on when it cuts off. Get it in before it cuts off. Make sure.
And Professor, you asked me to like resubmit the Mod 4. You just like commented on my submission that you gotta resubmit it. I didn't insert the tables. Remember?
Okay.
So like, yeah, I
Module 4. Okay.
I emailed
okay.
it to you.
Let me
You can just check it.
let me finish this and then we'll. If something is if something's wrong with one of them, I typically will take one at the end. I put a cutoff date on it because if I don't have a cutoff date, I will get somebody to, and usually it's 3 or 4 people, will hand me all of them on the last day of class. And that just, boy, I'm sitting there trying to get all my grading caught up and they just dump everything on me. And most of them aren't any good anyway. Okay, so I'm going to turn mine off. Close. Next.
Dr. Smith, I have a quick question.
Go ahead, please.
Just like with the practice test, it mentioned in there to use our default database, and
Okay.
our default database should be ScratchDB, right?
Yes.
But in part 2 of that, it referenced using tables that are in APDB.
Yes, your default database would be Scratch, so that would be the one you're creating a tables, right?
Okay.
You're creating I forget what it was. I have several versions of it. So let's say it's the doctor's patients database or something like that.
Right.
So I'm looking for that. Put that in Scratch just to keep from cluttering up your AP database.
Okay. Well, because like part 2 also said use your default database, but that referenced the invoice table and the vendors table.
Well, clearly that's a typo. Using it would probably, I would have to use the APDB.
Okay, that's what I did. I just used two using statements to switch between the two. So
right, that's the way you do it.
And I have a question on the same topic. We have to create the drop table in the beginning of the exercise or before moving from the part 1 to part 2?
You would.
Or we don't need to create the drop.
Yeah, you would have the if exists, then drop it before you create it. This allows you to run your script multiple times and to test it and then debug it.
So I need to create it twice, right? One drop for the first part and then another drop for the second part, right?
For the second part, if it's talking about the where you are creating tables. So you're creating a table, you should drop the table first. If you're not creating the table, drop it.
Okay, got it. Thanks.
Others. Okay, let's see. It is 11:54. It's about time for a bathroom break. And let me see what we've got coming up here. Test 1. Okay, I'm going to start on data aggregation. Okay, so we've covered everything that is going to be on test 1. So here's the break. Here's when we take the bathroom break. What I go into when we come back is not on test 1. Fair enough? Okay, I'm gonna take off my headset for right now. It's driving me nuts. Oh, I'm sorry. I was supposed to get back with you and my mother-in-law fell, and I ended up saying, she has Alzheimer's, and so she's in home. Very much off her head. And they take her to emergency. And she doesn't have enough hurting stuff. I mean, she's hurting. So we have to go there and sit with her for 3 hours. Oh, she can't do it. What are they gonna do with it? There till 10 o'clock. Hi there.
I mean, I just emailed you on Canvas, like the file. Everyone, I just like did it for module 4, right? So you just like check that. I just emailed you.
I won't tell you to do something and then take once away from you for doing it. Well, I don't suppose there's any sense in recording the break. I'm going to turn off the recorder during the break. Somebody remind me to turn the recorder back on. Turn the recording back on. And now we're going to go here. Okay, so this is the beginning of part 2 of the class. So part 1 was up through test 1, which just ended at the break. And now what I'm covering today will not be on test 1, so it's the next one. I wanted to bring up something I'd been talking about since we're doing the lecture on Wednesday, and then I will stay after class. Now, I can come on Monday morning, but I don't want to sit here by myself. Okay, if you don't have to come on Monday morning. Monday at 11 o'clock. You do not have to come, but if you don't come, I'm not going to come either. What I'm going to do, I think, from now on is if you need to see me, if you need some help and you need me to sit down with you, you have to email me and ask me to be here at 11 o'clock on Monday. If nobody does that, I'm not going to come in here because it is a fairly long drive. I mean, not long, but not like driving to Oklahoma or anything. But and basically, I haven't had anybody coming on Monday, so I'm going to be online. If you need to speak to me and you decide you want to, you can catch me online. I will be logged in, and all you have to do is connect, and my phone will ding, 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 and let me know that somebody connected, and I'll go over there and turn on my microphone. But if you need to see me, you have to do something to let me know that I'm not going to be sitting here all by myself. You know, it's kind of, I mean, why should I come in here to not have any students? All right, chapter 5. Oh yes, I need to do one more thing here, don't I? I need to find that. Let's see, documents. See, I think that is. Are they on my desktop? Copy. Okay. Let me see. That was module 2. I'm updating this create AP. Go to files, module files, module 2, upload. Okay, now on I've just updated that file. It's in module 2, page 5, and if you go there and download that file, create AP, and run that file again, I think it will make sure that you have the data that I'm using. It'll just recreate all your tables, and you can do that at any time. All right. So we've done the outer join, the aggregate functions. Okay, usually what I talk about here is the union and intersect first. So these are the set functions. Now these come in the textbook in the chapter before this. I choose to skip to go ahead and do test 1 without them. But union and intersection. When I talk about the union of two sets, and when you start talking about SQL queries, it is a set of rows. And if I talk about the union, I want everything that is in either set. So this will give me everything from set A and everything from set B. Let's look at, so the union combines 2 or more select statements into a single result, are in either side or both of the union. So A, union B, includes all of the rows that are in either A or B. And it typically contains no duplicate values, although you can cause it to have duplicate values. If you say union all. Here's an example. Select everything from invoices, union, select everything from invoice archive. Now, if it's in the invoices or if it's in invoice archive, it's going to appear in the output. And then there's an order by. The order by applies to the whole set of things that are returned. So invoice IDs 400, 300, and 400 come from the invoice archive table. The other 114 are from invoices. I can run that for you. So select everything. Typically, I indent it like that. When I execute, I'll get all of these guys. Now, notice these top two, since I sorted descending, the top two, 400 and 300, come from the invoice archive. If I were to go over there and look, I would find those guys in invoice archive. It puts them together. Now, it takes the names of the tables, excuse me, the names of the fields come from the first one. So they come from the first select. If the names are different, I will only have one name in the output, and it will be from the first table. The tables must have the same number of columns, and they must be type compatible. This means that, for example, I got invoice number is probably a character field. That has to be a character field in both tables. Terms ID is probably an integer. It has to be an integer in both tables. If it's a date time in one table, it has to be a date time in the other. They have to have the same number of fields in the output. Okay. Then you can take a union of them. Union is very handy when you want to see two tables just simply put together, one on top of the other. And then you can do a query against that. It's not a table join. It's just simply a concatenation of the tables. I just take table 1 and I put table 2 right below it. And then if I have an order by, I order the whole schmear. Okay. And then I take whatever names were in the first table. Go ahead.
What if the two tables have different field names?
Field names, you will get the names from the first table, the one on top. Will be the names. The types must match. So if they're out of order, it won't work. I mean, if I have an integer and a char in one table and a char and an integer in the other, I have to switch those back around before I can take a union. Could I scroll down? I don't know. Oh, here. Okay. That's a union. Now,
Will it give you an error if both tables are not exactly the same?
if they are not, well, exactly the same means that they must contain the same kind of information, the same number of fields, and they must be the same type. So integer, integer, char, char, date, date has to match. They don't have to be named the same. I'm going to take the names from the first table. I can get it with an as. I can stick an as in there and rename it in that first table, and the second table will just follow along. But they have to be pretty darn close before you can do a union. A union makes sense if I want to find, I've got a class of people, I've got information about students attending Collin College, and let's see, I have freshmen and sophomores, and if I have one table with freshmen and one table with sophomores, and I want to see those put together in one table, I can do that. And it's handy for things like that. No, it will not do. If the first table has one fewer columns, no, you could make it do a union if it were one fewer columns. For example, let's see, select invoice ID, invoice number from invoices, okay. Now, if I rename these, it'll I would rename them in the first one, and it'll just carry on through to the second. Now, notice that this one did just fine. Now, what if I didn't want the invoice? What if I did? What if I had it like this? Will that work? No. Why not? I don't have the same number of columns. This is not going to let me. This is going to give me an error message. It says, nope, can't do that. Now, I can make it work. If I say select invoice ID, comma, null, now they have the same number, and null matches anything. So now they have the same number of columns. So now it will execute. I'm just going to get a whole lot of null values in the output, and that's fine. I see the two I want, and then the rest of them stuck on there. So that's the way you can get around it when you union. Sometimes you have information in there. I want to put two tables together and sort, but one of them doesn't have enough values, so I can pad it out and still take a union. What's an intersection?
But I mean, if you will do that, you will do the other table first, right? So that you know which column that what other column that goes. Or you will
You are correct. I don't get I get no column name on that one, don't I? So you are correct. I could put the other column, had I switched the order, I would have taken the name of this one, the invoice number. And then again, I can just give it a name there on the first one. And I don't, if you just, I should have given it a name. Thank you for pointing that out, because all columns that are output should have a name. We're going to see that as we go. What is an intersection? If that's a union, what is an intersection?
only by second.
What? I'm sorry, I didn't, I guess.
Professor, I'm also getting an error. I don't have an invoice archive.
Okay, I'll have to look at it then.
So is it the same problem?
Did you run your, did you run the file I sent you just a second, I sent out just a second ago? Okay, it's in module 2, page 5. Go get it and execute that that guy again, and see if that doesn't fix it. Okay, intersection, those rows that are the same in both tables. So think of it like the intersection of a street. If I have addresses on one street and addresses on another street, I take the union. I want that they're on either street. The intersection is what's on both streets. Okay. You don't use intersection as much as you use union, but you also use it. Set difference, minus. Okay, they call it the except operator. That's difference. All rows from the first or the right table, the first one, and that should be the left table, shouldn't it? Let me edit that right now. The right table would be the second one. Intersect, except in the left. In the left or first table that do not appear in the second. By the way, here is a good little video on these guys. Intersection and union are the two big ones. Mostly, more often union than others. And basically, let's see, what else was I going to say about that? A full outer join. Full outer join. Why didn't I do full outer join? Full outer join is of A and B, table A. Full outer join B is table A, left outer join B, union, table A, right outer join B. So I don't need a full outer join, and I almost never use one. I don't believe I ever have in my life, but it's there in this one. Okay, here's where I wanted to get to today. Aggregate functions. We have several aggregate functions that everybody uses. You guys with me over there? Samna, we'll get that running. Follow along with me for right now. I promise you, we'll get that database up and running. Okay. I want to talk about these aggregates, and there are 5 of them that every database textbook does. I think there's about 22 of them given to you in SQL, but the big ones that they do are count, sum, min, max, and AVG, or some of them spell it out, but most of them it's AVG. So count. If I talk about the count over a row, what does it count? If I say select count, invoice number from something, what will I count? Okay, I count everything that is not null. Okay, so the count counts a field that's not, so for example, in select count vendor phone, I say count, I want to know how many phone numbers do I have in there. It tells me I have 97 phone numbers. Okay. Now, if I just want to know how many records I have in vendor there, I don't want to count, well, copy. What if I said count vendor ID? Now, vendor ID, I believe you will remember, I don't know why that's, vendor ID is the primary key. Well, what about a primary key? Everybody's got to have one, and it has to be unique. How will that be any different? Isn't that the same thing as the number of rows? And if I say yes, it is, there's 122 of them, so there must be 25 that don't have phone numbers. So if I said count where okay, where it's null, I should get 25. So there's probably 25 null values in there. Now, if I get 122, but if my objective is counting the records, okay, and I've told you that SQL is very well optimized. SQL is an artificial intelligence language. It is hard to write bad code in SQL, but here is one place that you can speed up your code. If I'm saying, if I want to count the number of records, it is better. So this is poor form. If I want to just count the number of records, you do better to say count any darn thing. So count asterisk says just count a record. Now, if I say to count the vendor ID, it's a little bit like I remember one time in when we were in Cub Scouts or something, and my scoutmaster told me to count the heads. Give me a head count. In other words, count everybody's head. Well, what if I couldn't see their head? So I'm saying, let's see, well, you got a head, yeah, you head, you got a head, you got a head, you got a head. So I've got to look and I've got to find the head and count it. But I'm not interested in the head. I'm just interested in, is there a warm body there? It's above room temperature. And so if I say that, now if I say count vendor ID, what the system has to do, it has to go into each record and make sure that there is a vendor ID there. But I know that a vendor ID has to be there. It doesn't know that. So it's going to go in and it's going to find the vendor ID. So it's going to go into each record and look. I say, don't look at the record, just as you see a record, count it. And that speeds it up quite a bit. So if you're just interested in a count of anything, for example, vendor phone. I want to know how many vendor phones there are, but I want to know how many we don't have phones for. So I would say count vendor phone. No, I don't. I'm not going to say count vendor phone. I'm going to say count anything from vendors That's a little bit better. It's not a whole lot of difference between those two, but anytime that you really don't care about what you're counting, you use the asterisk. Says, I don't care what I'm counting, just count any part of a record. And this should give me, I believe this will give me 25. Yes, it did. Okay. Well, we have, so count counts anything that is not null. So if I just say count vendor phone, it's going to give me back the count of them that are not null. If I say just count splat, it's going to give me back how many records I've got in that table. So count works on that. Minimum and maximum, min and max. What do you think those two do? Maximum value in that set. Okay. So what's the biggest phone number? Well, that wouldn't make much sense to ask really, but kind of like what's the average phone number? Min and max apply to anything. They can be applied to alphabet. So I can find the greatest text string, the minimum text string. Minimum and maximum do not apply to nulls. So a null will not be the minimum, even though the null will come at the beginning if you order by a field, and that field has null values in it. The nulls will come at the beginning if you're sorting in ascending order. If you sort descending, they'll come at the end. So it leads you to think that they're less than everything, but null is not the minimum value. We don't know what null is. We have to put them someplace in the order, so we just put them at the beginning. But if you ask for the minimum birth date, in other words, the person that's the youngest, if you don't have a birth date, that won't be the minimum. It won't be the maximum either. It just won't, it won't find it. Okay. So nulls give us a lot of trouble on these things. Anytime you're asking for minimum and maximum, you got to watch out for null. Because what if the whole row, what if the whole range were null and you ask for a minimum of null? What you would have would be an error. So minimum, maximum. So I have count, I have minimum, maximum. That's 3. I have 2 others. One of them is average.
If you go average, you will to get the average, you will pass by the nulls?
Nulls do not count to average. Nulls aren't counted as zeros. Nulls just aren't counted. So if you have a null in there, that doesn't count as a 0 unless you say to count it that way. And there's a way you can, but you're going to have to work that out. So average takes the average of, and it has to be numbers. You can't take the average of a person's name. Similarly, you have the sum, where you can add them up, add up a range of numbers, sum. If you take the average of, and you don't have anything but nulls in there, you get an error. You can't take an average of nothing. Why not? Because you have to divide by how many, and you're dividing by 0. You can take a sum of nothing, and is that 0? I think it's defined as 0 in database. It'll give you 0. So if you don't, if you take a sum but you don't have anything to add up, I think it gives you back 0. If you take an average of something and you don't have anything to average, you get an error. Okay. Now, I'm not going to go too much longer here. Now, what about this one? The students usually don't have a problem with aggregate functions, those 5. What do we have? Count, min, max, average, and sum. Those 5 are done all the time, and those are the 5 that we're going to do. They're the ones that are in our textbook. They're the ones that have been in every textbook I've ever touched, the database. It always does those guys. Now, students usually get those down pretty well. I ask, well, what if, find the average invoice total? And students just say, that's pretty easy. Find the average invoice total. Select AVG. Invoice total. And I could say find it for a particular vendor ID. Lots of things I could do there. And this is pretty simple. And the average invoice total is $1,879.74 Well, okay, money, when you have money is calculated always to 4 decimal places, okay? So just get over the fact that whenever you have money and you take an average, you're gonna see that penny taken out to 4 decimal places. Did you know that there is a coin that exists? The coin has to exist, and 100 of these coins make a penny. Yeah. It wouldn't be worth, if it were laying on the floor, it wouldn't be worth, it'd just be litter. You just sweep them up and throw them away. They're too much trouble. But those are called mills. They have to exist. They're not in circulation. You can't go out and get one. But since money is always calculated in 4 decimal places, and that's just something to remember. So you're going to get those extra 2 decimal places on money. Right? Okay. Now, where people have the point that people have the problem, where was it? Average invoice total. Let's see. Vendor ID. Now, what am I wanting to see here? For each vendor ID, I want to see the vendor ID and the average of that vendor's invoices. Okay, because the vendor can have multiple invoices, and I want to see what the average is. All right, if I do this, I get, for my reading pleasure, an error message that says I cannot do that. It says invoices is invalid in the select list because it is not contained in either an aggregate function or the group by clause, and I'm about to tell you what the group by clause is. So it's not contained in an aggregate function. What's an aggregate function? We're going to talk about 5 of them: count, min, max, sum, and average. Okay, it's not in any one of those, and it's not in this new thing that's come up, group by. Okay, new rule. New rule. If you have in the select line an aggregate function, one of those 5, one or more of those 5, you can have 10 of them. So if you have any aggregate function at all, and you have anything that is not an aggregate function, here I have the simplest case. There's my aggregate function, the average, and there's my not an aggregate function. New rule applies. I have something that is not and something that is an aggregate function. Those things that are not an aggregate function must be grouped. What do I mean grouped? When I say group by vendor ID, I say collapse all of the vendor IDs where they're the same, collapse them into one row. Now watch what happens when I put a group by in here. G-R-O-U-P, by, group by vendor ID. So everything that is, all of the vendor IDs will squeeze down into one row where they're the same. And if they're not the same, it'll still be one row. So I have 2 vendor IDs. Those 2 will give me one row, and then I will get the average of the 2. And let's throw in another one up here since we're here. Let's say count. And I'm going to say count star because I don't care what you count. Just give me a count of the rows. So I want to see the average, and I want to know how many of them we're averaging to get that. And so when I run this, now, do I meet my new rule? I have got a non-aggregate and an aggregate. Actually, I got 2 aggregates, but I don't care. I've got 1. That's all I have to have, 1 of each. If I got more, that's fine. Okay, and when I execute this, I get my 34 rows. So for each vendor ID, I see the average. Now, I really should have put as A, don't forget to do this, please. Don't forget to put the, to alias that column like I just did. Do as I say, not as I do today, okay? So as A, count as C. It's okay to be terse. Name it A is fine. A for average and C for count. That's fine. So vendor ID 34 has an average of $600.06, and 2 of them make it up. Vendor ID 48, for example, has an invoice ID average of $856.92, and only 1 of them, well, that 1 has to be $856.92, doesn't it? Look at this one, 95 has 6. Whoever 121 is, they have 8 invoices. 122 has 9. And it's giving me the average and telling me how many it averaged to get that. Okay. I could also add max, I could add min, sum in there. As long as, if I have anything except an aggregate function, I have to group by. Now, if you think about it, what could I possibly want if I didn't want to be grouped by? If I didn't want you to collapse vendor ID, what else could I possibly do? Now, it's going to be this way in every database you ever touch. Okay? This isn't just about SQL Server. It's going to be this way in Oracle, and it's this way in Access, and that's just the way it goes. That's just how they work. So when you're in Access and you have any aggregate function, As soon as you put an aggregate function into the query, the rest of them all automatically go to group by group by group by. And that confuses students to no end because they'll add something like count and they have a whole bunch of other stuff. So they're grouping by all that other stuff. And they, it ends up not collapsing like they want it to. Typically speaking, most of the time, not always, most of the time, you're really interested in one field that you're grouping by. I want to see everything broken out by vendor ID. I want to see the vendor name and the count of the invoices. In that case, I'd need a join. So suppose I wanted to see, instead of vendor ID, suppose I wanted to see vendor name. How would I do that? Say what? Suppose I said vendor name instead of vendor ID. Oh, I have to group by. Okay. But it's still giving me the red squiggly thing. What's the problem? I don't have vendor name in invoices. Oh no, oh woe is me. What do I have to have? Enter join invoices. That might be a test question that you see before you get out of here. It won't be one that you'll see on test one because I told you that that wouldn't be there. Now, if you think about it, so what? I've got vendor name in there because I put vendor name. Vendor name is in another table. How are the tables joined? On vendor ID. So I had to join them, and now I will get the same information, but instead of the vendor ID, I'm now seeing the vendor name. So yeah, okay. 47 of them. So there's 47 from Federal Express. You can order by that guy. And let's see, we're coming up on 12. You can order by the aggregate function. Yes, and it would actually I can order by the alias, because remember how that works. The select line, well, the first line that is evaluated is the from. So if I have V and I showing up on that select line, those are going to be visible all the way through the query. Then after the from, we get the where and any group by, anything like that. And then finally, we get the select, comes last. So, and then the very last is order by. So order by C would be fine, because I can see that these aliases I can see in the order by line. But if I tried to say where C is greater than some number, it isn't going to work. Execute. So now it's ordered by C. Questions? So I can use those select line aliases in the order by column. Okay, I'm going to wrap it up here. Let's see. I need to make the assignment from let's see. Where's my modules? Here they are. We got an assignment from chapter 4, the outer join. So outer join has, we've got an inner join, outer join. I'm treating them as 2 assignments, but they're really 1, so it's 20 points and 20 points. So they're fairly short. When am I going to make this due? Up here in edit. When is he going to be due? I suggest you do the outer join as soon as you can. I don't want to make the outer join due the same day as the test 1. I'm going to make it due a week from today. Okay. And I will put out an announcement on Monday mornings. So Monday mornings, you're going to have to contact me if you need to see my physical face. You can still see me in, well, I have a camera on my home computer. I don't have a camera here. So I will be available to meet with you, talk with you on Zoom on Monday mornings at 11 o'clock to 1 o'clock, I believe. And so I'm just going to, by default, I'm going to log on. Just a minute. I'm going to log in and just be there. I'll be somewhere where I can hear it. If you just connect, I'll hear it chime, and I'll get in there. Okay. Okay. I'm going to pause the recording. Everybody online happy?
Yeah, we're good.
Okay.
Okay.
I'm going to pause the recording.